Back in 1819, one simple experiment completely flipped our understanding of the universe. It revealed a secret connection between two of nature's biggest forces, and honestly, it changed the world forever. Let's dive into Oersted's incredible discovery.
For the longest time, electricity and magnetism were seen as two totally different things. Electricity was all about sparks and lightning, and magnetism was about compasses and weird rocks that stick to each other. They lived in separate chapters of the physics textbook. But some scientists had a hunch that there was a deeper connection, a secret just waiting to be found.
So yeah, this was the big puzzle. Plenty of people had tried and failed to find a link, but the answer, as it turns out, was right around the corner.
And the year that corner was turned was 1819. The man of the hour was a Danish physicist, Hans Christian Oerst. He's the one who finally cracked the code, linking electricity and magnetism together for the very first time.
Oersted had this gut feeling, a theory. He thought, what if an electric current, the flow of charge through a wire, what if that actually creates its own magnetic field that kind of radiates out from the wire? To put this idea to the test, he set up a beautifully simple experiment. The experiment that changed everything was just so elegant. All it took was a wire, something to power it, and a regular old compass.
Okay, so here's what he did. First, he took a wire and lined it up with the Earth's magnetic field, so his compass needle was pointing right along with it. Then, he passed an electric current through that wire, and what happened? The compass needle immediately jumped, swinging around to point perpendicular to the wire. Just like that, the connection was made.
And here's the real clincher. When he turned the current off, the needle went back to normal. But when he reversed the direction of the current, the needle deflected in the exact opposite direction. This was the smoking gun. It was undeniable proof that the electricity in the wire was generating its own magnetic field, one powerful enough to boss around the Earth's own field.
So Oersted proved the connection. Awesome. But like any great discovery, it immediately led to a brand new question about this invisible force he just unleashed.
I mean, think about a regular bar magnet. We all know what that field looks like, right? It's got those clear north and south poles with field lines looping from one end to the other. But a field around a perfectly straight wire? What in the world would that look like?
Well, you can actually see the shape if you sprinkle some iron filings around a wire with a current running through it, and the result is stunning. The field wasn't shooting straight out from the wire like you might guess. Instead, it formed these perfect, concentric circles all the way around it.
And this observation got its own name, Oersted's principle. It's now a fundamental law of our universe. Anytime you have charge moving through a straight wire, you get a circular magnetic field around it. It's simple, it's elegant, and it was absolutely revolutionary.
And further tests showed something else that makes intuitive sense. Kind of like ripples in a pond. The magnetic field is super strong right up close to the wire, and then it gets weaker and weaker the farther away you get.
Okay, so knowing the shape is a circle is a huge piece of the puzzle. But which way is the circle spinning? Clockwise or counterclockwise? To figure that out, physicists came up with a really clever and simple tool, the hand rule.
Now, hold on. Before we get to the rule, there's a quick but really important detail we have to cover. Way back when, scientists guessed that current flowed from the positive terminal to the negative one. We call that conventional current. Turns out, they had it backwards. We now know that tiny electrons actually flow from negative to positive. Because both of these models are still used in different contexts, there's a hand rule for each.
So for the old-school conventional current, we use the right-hand rule. You can actually do this with me right now. Take your right hand and point your thumb in the direction the current is flowing. Now look at how your fingers naturally curl. That's it. That's the direction of the magnetic field. Simple, right?
Now, if you want to use the modern, more accurate model of electron flow from negative to positive, you just do the exact same thing, but with your left hand. Point your left thumb in the direction of the electron flow, and your fingers will curl in the direction of the magnetic field. The physics is identical, the result is the same, you just switch hands.
To show all this on a flat piece of paper, physicists came up with a handy little symbol. Think of an arrow. An X looks like the tail feathers of an arrow flying away from you, so it means the current is flowing into the page. A simple dot looks like the tip of the arrow coming right at you, meaning the current is flowing out of the page.
So, Oersted saw a compass needle wiggle. Big deal, right? Oh, it was a huge deal. It didn't just solve an old physics mystery, it literally laid the groundwork for the entire world we live in today. The impact was just massive.
For the first time ever, magnetism was controllable. We could turn it on and off with a switch, we could make it stronger or weaker just by changing the current, we could even flip its direction. This one principle is the beating heart behind every electric motor, every power generator, and basically countless other technologies that run our modern lives.
You know, oersteds showed us that two forces that seemed completely separate were really just two sides of the same coin. And it makes you wonder, doesn't it? As we look out at the universe now, at mysteries like gravity and quantum mechanics, what other huge fundamental connections are just sitting there, waiting for someone to notice a compass needle twitch?